Okay, so welcome everybody and welcome to this CIRCASA webinar. Today we're going to talk about the COMET Farm tool, and as you may know, this is a platform that is being developed by Colorado State University. And today we have two special guests with us that I'm going to present later. So you may know a little bit of this platform is used to quantify carbon and other greenhouse gases emissions on a farm or a ranch scale. And we're going to talk about what are the current applications of this platform in the context of the USA. Later in this webinar, we'll also talk about the Comet Global prototype that is based on this Comet Farm tool. And this is being developed and could be used as a decision support tool. And our second speaker is going to present it to us. We are also mentioning and talking on why is this, how can this contribute to CIRCASA International Research Consortium that we are preparing for by this year. So if you want to know more about this International Research Consortium, I invite you to go to CIRCASA webpage. You can also visit their Comet Farm tool at comet-farm.com to see how this platform looks like. And also I invite you to stay until the end of this presentation because we are going to have a short demonstration of this tool so you can see how it looks like and how it works. So our two special guests of the day, we have first Keith Paustian with us. Hello.
Hello.
He's from Colorado State University and he's professor in the Department of Soil and Crop Sciences. And he's also a senior research scientist at the Natural Resource Ecology Laboratory. He mainly works on the modeling and field measurements and development of assessment tools from carbon sequestration. Our second guest is Kevin Brown. Hello, Kevin. And he's a lead software engineer, also at the university. And he helped architect and develop this Comet Farm tool that we're going to see right now. He's also director of the research software facility at Colorado State University, and he's leading a team of developers working on the tool that we are going to present today. So thank you everybody to being here today with us. And just before starting, I would like to remind everybody that this webinar is going to be recorded. So if you want to watch it later. So I now give the floor to Keith and welcome everybody.
Okay, thanks, Sorry, let me see if I can get the screen share working here. And okay, well, welcome everyone. And I'd really like to thank CIRCASA for the opportunity to participate in this webinar. And before we get started, I'd also like to acknowledge our other team members that are that I think at least one or two are on the webinar now. Mark Easter and Amy Swan, both in my research group at Colorado State University. Also, Dr. Adam Chambers, who's with USDA's Natural Resource Conservation Service, and Adam is our program officer for our work that USDA has been a partner in the development of the tools that we're going to be talking about today. So, so without any further ado, I will go ahead and then proceed. So I'm going to talk first about the Comet Farm tool, which has developed over probably more than a dozen years, again, in a close collaboration between Colorado State University and USDA. And then I'm gonna, after I give the introduction on what we're doing with the tool in the US, then Kevin is gonna take over and talk about a new initiative to develop the Comet Global system. So we all know that you know, there's a lot of interest now in various land-based you know, both carbon removal solutions, but also, you know, how can we change our land management to improve soils, to improve climate resilience. So this is really an imperative globally now. various ways to do that, but we can do that within our cropping systems, our pastures and range systems, as well as in agroforestry, orchards, other, really any kinds of agricultural systems have opportunities to improve substantially carbon storage and improve soils. So if we think about, incentives and how can we move producers to adopt more conservation practices? What are the policy levers, if you will, to also try to incentivize really carbon dioxide removal into soils and sequestration there? How can we do that at scale? I think there's various policy levers. There's government subsidies and incentive programs. They're within the US, obviously USDA, within the European Union. Very important programs there as part of the CAP. In states in the US, for example, in California, a Healthy Soils program. So these are important, often first movers in terms of incentive systems. There's also growing carbon markets by which producers could be, farmers and ranchers be paid for producing environmental services, including soil carbon sequestration, including greenhouse gas reduction. And then also there are sustainable supply chain efforts by companies that are producing agricultural products that are interested in having a low carbon footprint of their product. And one of the ways to do that is to go and improve practices within the farm gate, because that's where a lot of the emissions are really associated with the production of the finished product if it has an agricultural origin. So there's these different policy levers, and so there's certainly ways to make this happen. But I would say for any of these basic policy levers, market-based solutions, it's really important to have reliable metrics. Okay, and so ideally we want to have something that is locally scaled, give us information at the farm scale. We want estimates that are unbiased with a known uncertainty. They've got to be cost effective, and they've got to really include all the different aspects of management, because there are, management can affect multiple gases. It can affect multiple, parts of the overall carbon and greenhouse gas situation for a farm. And they've also got to be easy to use. And this is a challenge because we know that both carbon sinks and sources, as well as other non-CO2 greenhouse gas emissions, they're dispersed, they're non-point source, they vary a lot in space and time. There's a lot of different things that affect the processes. So whether it's climate and soil type and historic management, et cetera. So there's a lot of different things that can change these. We can, of course, directly measure carbon stock changes. We can measure gas fluxes, but often to do this well, we need specialized equipment and training. I would say it's in many ways more of a research environment undertaking to do it well, and it's certainly, at the present time at least, it's too expensive to routinely deploy these kinds of measurement tools on every farm that wants to be participating in a carbon market, for example. So I think that really leads to the kind of the fundamental basis for what we've been doing, and that's the idea that we want to use model-based systems that are supported by data from experiments and from soil monitoring networks, et cetera. But we really want to have the modeling tools be kind of front and center at the core of the quantification. And so today we're going to be talking about two of the tools that we've developed. On the left-hand side is the tool called COMET Farm, and this is a dynamic tool that is available on the web, and it is really designed to do this farm level greenhouse gas accounting And again, as I mentioned, it's been developed probably over about a dozen years or so within my lab and with USDA support. We then developed a second tool I'm just going to talk briefly about, is something we call Comet Planner. And it's really, think of it almost as a meta model from Comet Farm. So Comet Farm contains the basic science package that does the estimates at the field scale. Whereas Comet Planner, then what we've done is we've taken literally millions of estimates generated with the methods within Comet Farm and created essentially regional average impacts of adoption of standardized conservation management practices. So it's a tool that is simple to use, and it has a different kind of a application for particularly for perhaps government planning purposes. So we'll get a little bit more into particularly the Comet Farm now. First, just to again emphasize the fact that the COMET tools are really a systems approach to greenhouse gas inventories, and this is a cartoon that many of you probably seen, was in the IPCC 2006 guidelines for AFLU inventories. Actually, Amy Swan, who's in my research group, she at the time developed the cartoon, and I think it's a nice illustration really to show the various kinds of both gases and sources that we're dealing with in agriculture. So we've got a lot of different sources, we've got different gases, and when we need to really look at the totality of those. So we need a holistic approach. In the US, about 6 years ago, 2014, this blue book on the right-hand side that you see there was published, and it is USDA's methods for entity scale greenhouse gas and carbon inventories for farms and ranches. And this was part of about a 3-year process in which they had teams of scientists from academia, from government, from industry that got together into working groups, went through and selected the methods that should be applied, that they recommended at the field scale, and then it went into quite an extensive review by peer review and government review, public review. And so now there's this, so think of it a little bit analogous to the IPCC inventory task force in terms of producing a set of guidelines, but this is specific for the US, and it covers again all the various gases and sources within the land use sector. And so this compendium, or this set of methods, is really what is implemented within the Comet Farm tool. So the Comet Farm tool is really aligned with and designed to allow the user to make estimates using this methodology. So part of the one of the primary purposes of Comet Farm, certainly originally, was to allow farmers to look at potential options of changing their management, of adopting different kinds of conservation management, and see what would that potentially do on their particular operation in terms of sequestering carbon, reducing greenhouse gases. So the Comet Farm system is set up that the user puts in their information on their current practices. So think of it as a baseline, and then it can choose and really tailor virtually any kind of management change that they want to adopt. And I'll talk about some of these here in a minute, but it can include changes in tillage, changes in crop rotation, in nutrient management. It can involve shifts in land cover types, conversion to grassland, planting of trees, lots of different things like this. And the tool really allows you to do detailed field-specific analysis, and it also, you on the particular farm, you really specify what your baseline, what your current management is, and then it involves really, as you're entering the information in that, then actually the system is doing dynamic on-the-fly calculations using a suite of different models. So that's kind of the Comet Farm system. It's really geared to an individual farm, an individual field. And I mentioned before the Comet Planner tool, which is really a derivative, and it's set up to be, you know, I like to call it the 4-click tool, because basically what it does is it takes a conventional management as the assumed baseline situation within a regional context. And then it allows the user to say, okay, I'm in this particular region. Now I want to look at a suite of conservation adoption scenarios. And these are defined operations that have been developed and prescribed by USDA's Natural Resource Conservation Service, and so they're really in a suite of menu choices. So once you go in, you identify the area that you want to apply the practice to, and you select the practice. Then you get an estimate of what the conservation benefits in terms of carbon or greenhouse gases are. And this has been used, for example, in California for their Healthy Soils program, in which they are able to get payments for conservation practice adoption. And as part of that program, they use the Comet Planner tool. There's a number of other states within the US currently now that are also looking at Healthy Soils programs. And there's a lot of interest in using this kind of tool to support them. So back to Comet Farm tool, and this really is designed to give you an idea of the system. And I guess I would emphasize that it's really it's a platform in a sense. And here you can see, you know, the user is sitting here, goes online, and is really key in terms of defining both, you know, where's the farm located, where is what are the previous practices, what are the practices that they want to explore in terms of conservation scenarios. And you can see here in this upper part of the diagram here that it can be entering all the management data that relates to croplands and grazing lands, but also their livestock operations and energy use, agroforestry, etc. So the user inputs are really what drive this system at this individual level. Then within the tool, there's a number of back-end databases that include climate and soils and land use and land cover, information on typical historical management practices, etc. So these are databases that are kind of embedded within the tool. And then there's a calculations module, and this really is not just one model, it's a whole suite of models. And so, for example, in the US, we use the DayCent model for soil carbon and soil nitrous oxide emissions within this system. And but there's a number of other models of various kinds, empirical models for other emission categories, etc. And then there's a reporting module. And also with the calculations that are done, we have an uncertainty estimator, which is different for each of the particular subsource categories. So now, just to quickly get kind of an idea as a user coming into this, what it looks like. We don't want to spend a lot of time doing it, but it's certainly you know, available and people can try it out. Again, the caveat to that is right now, this tool that I'm demonstrating here, I'm showing is really set up to work in the US, but you can certainly access it. And if you just pretend you have a farm in Colorado or somewhere else, then you're welcome to do your Comet Farm scenarios. So this gives you an idea when you go into the tool and you select the type of systems that you want to look at. One of the first things that you're led to do is to define your land areas that are being managed. And you can do this either by drawing a polygon. We've got different tools where you can draw a circle if you have a center pivot irrigated system. You can also put a point down to and indicate the area that represents to get an approximate you know, location for the field. But this screenshot here also illustrates the fact that there's a soil map that is underlying this this land cover and the field designation. So here you can see different map units, and this is from the USDA's SIRGO soil maps, which are about 1 to 15,000, so they're quite detailed, as you can see here. So within this parcel, there are a number of different soil types which have different textures and potentially different depths and rooting environments, etc. So just to point out that when we do the estimates for soil carbon and nitrous oxide, the system is actually, the management is defined at the parcel scale, but then we are doing the calculations and the model runs for the individual soil map units that are within the field, because they can get quite different responses, and then we area weight average those results. This gives you a little bit of an idea of the, once you've defined your areas, then you go to a next screen, and you can use this drag and drop facility as a way to very quickly set up your management scenario. For example, if you want to specify your baseline, you can sort of grab a crop and move it over into this panel here, and then specify whether it's irrigated and what the tillage type is. And essentially then you're provided with a lot of default information about nutrient management and other things, which is regionally specific, and you can run the model using those defaults. And I apologize, you can't quite see it here, but underneath here, so if you choose not to use this drag and drop, you can actually go through and enter the specific details about the planting dates and harvesting dates and your crop rotation and your fertilizer. Have you added manure? How have you managed the crop residues? Have you burned residues, irrigation amounts, types, intensities, etc. So you can really enter a very detailed information, but you can also, if you want to start off by using this kind of set of defaults, then that's available too. And we're currently, I'll just mention it now, but we're currently working also on developing a kind of a system that will use a lot of estimates from remote sensing in terms of tillage, historic tillage, and crop rotation, and whether cover crops have been used to sort of auto-populate the management as well. But of course, that can always be edited by the user. So once you've entered your baseline management for all your systems, depending on how you've done that, then you get to enter your scenarios, your conservation scenarios. And again, you can select any type of management in your projection period, and that you choose to, in terms of the tillage and the cropping and the nutrient regimes, etc. But we've also got it set up here that if you want to select sort of pre-built conservation practices of various kinds, like cover crops or tillage changes, then you can simply select from a menu and then go ahead and implement that as your practice. Once you've defined your baseline scenarios and your management change or conservation scenarios for all the different fields that you want, and you can also set up to do multiple different conservation scenarios, I think up to 6 or 8 or something like that. Then the system runs and returns the results. And so here's an example of the standard output. You can also produce graphs, but you get these tables, and the tables have this kind of accordion-like function, so that you get the data for the whole farm, but you can drill down into an individual field and look at the various source categories for emissions or carbon stock change. And you get values that are on greenhouse gas, carbon dioxide equivalents to total up for your parcel, and then totals for your entire farm. We also allow the user to export the data into a spreadsheet or other kind of form. So there's a lot of flexibility there. And also I mentioned before that we have uncertainty for all the different source categories. We're still working on a couple, but we use again, uncertainty estimation methods that are recommended in the greenhouse gas guidance. And in many cases, that's a Monte Carlo based uncertainty. So you can zoom in on the uncertainty and get the definitions of what those estimates are, along with the distribution. We also have an application program interface that allows for other programs to access the COMET Farm system from the outside. So you can have a different kind of a user input system. You can have a different tool entirely. The API runs in the Google Cloud, so we have that scalable. We've got a few users now that want to come in and do big batch runs of hundreds of thousands of simulations. So that's also available. So then finally, you know, what's happening with these tools in the US? And I mentioned before that, you know, the major part of our support has been with USDA, and so the tools were originally developed to help support the conservation planning and government programs that USDA sponsors. And they continue to be a really important use of the tools, but also, I mentioned before, a number of state governments are looking at healthy soils programs, or looking at state level policies for greenhouse gas reductions. And so we've got a lot of interest from different states. A number of companies are using it for, again, these kind of supply chain type of initiatives. Carbon finance, a lot of the methods within the tool have been used for some of the protocols in some of the registries, such as the Climate Action Reserve. We're also working with a new company called Nori that some of you might have heard about, that is developing a carbon finance platform with blockchain, and as part of their quantification, they're using the COMET Farm tool. Done a lot of work with NGOs, particularly in the US, again, with Environmental Defense Fund and Nature Conservancy and American Farmland Trust. Got quite a few education users in both classes and other kinds of things. So that kind of gives you an overview of what the tool is and how it's being used in the US. And so I want to pivot now and talk about really going global. And what we are really proposing to do, and what we've got a prototype of that Kevin is going to talk about, is to develop this concept, but to do it in a way that is very flexible and allows for a kind of a plug and play architecture. And a major reason for that is of course that the different countries and different regions can have their own, they're going to have their own specific data sets, whether they're climate and soil maps and other kinds of back-end data, but they can also have, their particular models or their particular methods, and so you need to be able to accommodate that. We want to have a way in which the different users can essentially add spatial layers and methodologies that can be specific to their to their problem. So here you again see the user is there, and is in the driver's seat, if you will, and the data will we're still talking about farm specific capabilities. The management data, whether it's entered by the farmer or maybe estimated through some remote sensing data, et cetera, that's still at the specific farm level. But then now some of these back-end databases that drive the system, these would be region specific or country specific that determine what methods and stuff are also being used there. So I think now I'm going to go ahead and stop sharing, and I'm going to turn it over to Kevin to pick up with how we are. Let's see. I think I'm stopped sharing now, haven't I?
Yes. Thank you, Keith, for this presentation. I think it's pretty clear. I see that Amy is answering some questions, and thank you too. And just a reminder, we are going to try to answer all your questions at the end of the presentation. So, because maybe we're going to answer during the presentation. So please, Kevin, I give you the floor.
All right, thanks a bunch. I'll share my screen. Okay, so as Keith mentioned, Comet Global, really the goal is to make a global version of Comet Farm. So, we learned a lot working with Comet Farm. I've been working on it for the last decade, so we've learned a lot over that time period on what improvements could be made to allow for Comet Farm to be a scalable tool that can be used at a global scale. So I've got a graphic here that I wanted to show, and I'll zoom out just a little bit. Won't go into the details here, but I believe this graphic really helps characterize the Comet Global system. It really is it really is designed to be scalable, flexible, and it's something that's collaborative as well. And we really wanted to focus over here on the models so that more models can be plugged into Comet Global dynamically and with less development effort. And so in the next slides, I'll go into detail on these specific modules that will help this platform be plug and play so that as many collaborators as possible can add their data sets and produce useful reports for the users. But let's go into some of the differences between Comet Farm and Comet Global. So Comet Global is, again, it's designed to be a global tool. So the very first item is languages, that they need to be dynamic. Currently, Comet Farm is just one language, and that's typical English language, but we'd like to design, Comet Global, and we do have a prototype that actually works with language translation, but for different languages to be easily dropped into the website as they become available. I'll go into more detail on the architecture of the multi-language platform. That was essential for the Comet Farm, for the Comet Global tool. And then the greenhouse gas estimate methods. Again, we want these to be nation-specific or region-specific, and we would like to have a default IPCC for global applicability. And then the regions, we want those to be dynamic as well. One thing we notice with Comet Farm is that sometimes when we have someone trying to use the server from a remote location, Australia, Spain, France, the network latency becomes a big deal, especially when trying to run the simulation 3 models, and there's not a lot of the distance between the server, the remote server where Comet Farm is, and where the IP address is for the user is so different. So we're going to have dynamic regions. We're going to do that by hosting our software application in the cloud. And then spatial layers, I'll go into that in detail. It's a very important component. As Keith mentioned, in order to produce a Comet Farm report, there's a checklist essentially of requirements that can include weather data, soils data, user data, all these different data types that are usually spatially, that have a geospatial component to it. We want that to be dynamic in Comet Global so that this can, so that these data sets can be plug and play. And then we also want to have fully parallel computations as opposed to in Comet. Right now, the Comet was originally designed over a decade ago, and over time we've improved the system and have made upgrades over time. But currently, Comet Farm is only partially parallel. So I'll go into detail there. So architecture. So Comet Global is designed to be collaborative, scalable, flexible, user-friendly, and transparent, widely available. That's our goal. And so with the collaborative effort, Comet Global is going to be completely open source from the onset. And it's also going to be a multi-language tool, as I mentioned earlier. It's going to have those dynamic spatial layers. These are points that I'll go to in more detail in the next few slides. So open source, really straightforward, open source license, and we're doing that to encourage collaborative efforts, to invite established software development teams, research teams, scientific teams to add their knowledge and databases and repositories and models to this platform. And all the software is going to follow a design pattern. So code commits and code reviews are going to be a requirement, which will help stabilize the development environment and just allow any number of collaborators to participate in a seamless manner, so we can scale up participation. The multi-language platform. So there's a lot of ways currently to do language translation, and some language translation tools attempt to automatically translate sentences, and I think if you've experienced that, sometimes the sentences that are automatically translated aren't very accurate. And in a scientific setting, further, you really have to have a translation that allows for manual override if the automatic translation doesn't work. So Google has an amazing translation API that's available through their cloud platform, and it does more than just automatically attempt to translate a sentence for you. It actually allows you to provide a learning module so that you can train it to better translate sentences, but it also allows for, most importantly, allows for you to override any sentences that are incorrect or inaccurate. So the idea here is that in that collaborative environment, if we have a group that's responsible for the French translation, they can go in and not only train the model, but also provide specific overrides for various different sentences throughout the website that need to be edited or tweaked. And that's all going to be done through a protected hierarchy with proper administrative controls and protection, so that only the approved personnel can make those changes. So that's going to be a really cool one. All right, let's talk about dynamic spatial layers. So when I say dynamic spatial layer, what I mean is just a data set that's spatially driven, that can be used to either provide defaults or some sort of data set in the back end. And this is on the right here, you see a specific screenshot of the Comet Global app, the current prototype. Well, maybe try and zoom in here. Yeah, I probably should have done the PowerPoint. I just had the PDF pulled up. That's all right. What you see on the right here, and then we can provide the PowerPoints specifically as well, is just a screenshot of a global data set that's being pulled, and it's on organic carbon. I'm highlighting Europe for this data set, and this was pulled in 10 minutes. And visually, you can see the data set, but then you can also use it on the back end to provide, again, defaults for user data or whatever. If there's a model that needs a specific data set, then we can provide that through the dynamic spatial layer architecture. Okay, so there's inputs and visualization. One thing about this platform is that we wanted to design it to be scalable, so that we'll have fast spatial layers that are served no matter where you're at. If you're in France, if you're in the United States, if you're in Australia, we want it to seem like the server is right in your backyard. We're able to achieve that through the Google Cloud Platform. And specifically, we're using GeoServer to standardize a dynamic spatial layer architecture with those two goals in mind. Everything will follow a very specific design pattern. And if you've used R, the the stat library software, if you want to add an R package, you have to follow a specific design pattern. And so we'll have a similar design pattern where you have to follow certain rules, and we'll have a flexible rule set. And if you do, these new spatial layers will be able to be added to this platform pretty seamlessly. Okay. So dynamic models. Again, Comet Farm, one of the goals is that we wanted to have here with Comet Global is to be able to add in models more easily, more quicker, and you know, for the global tool, that's imperative that we, you know, who knows who might have a useful model, and we want those models to be as plug and play as we can make them. And so there's an aspect of the architecture that involves where we put the code, where we put the wrappers that run the models, that drive the actual reporting. And so we decided to put these dynamic models into cloud functions. When I say cloud function, this is a specific term that I don't know if it's coined by Google, but we use it in the Google Cloud Platform. And it's just think of it as a piece of code in the cloud. And what it allows for is independent code sets that can be auto-scaled in multi-region, but that can also be invoked from our cloud platform, you know, anywhere. Okay, and it's best to maybe show a demonstration of what that might look like, and in a later prototype we'll have a specific code example of what that looks like. I think the takeaway here is that we want to provide a way for any collaborator to add in their models as dynamically, as quickly as possible. And we can achieve that through cloud functions that follow specific design patterns. Okay, which goes kind of with the cloud functions. Everything's in the cloud. You'll hear that throughout the Comet Global theme: scalable, cloud, and multi-region, all these things. So cloud databases is same concept. Databases in the cloud, widely accessible, fully configurable permissions. The cloud databases, they're meant to be auto-scaling, and so if there's more traffic, more demand, they automatically scale, so that we don't have to, you know, manually deploy and upgrade to a server or, you know, anything like that. We want for auto backups as well. And this is all an architecture that we actually currently have in place, and we have a working proof of concept of this. Okay, and also really important are the configurable permissions. So if you have an important data set or a data set that a collaborator wants to contribute, the permission hierarchy is really important. So we do have a fully configurable permission hierarchy where there's a team lead, that's the admin, and then the admin has the ability to grant permissions to any number of users as they see fit. So I think it's really cool. Dynamic user interface. So as a leader of the software development team for the Comet architecture, whenever we added a new user input, so let's say that we wanted to do liming calculations, and so now we need to add in a new user input for liming. Well, in Comet currently, that's a very specific effort where we need to go in, add an input called liming, and manually program that page to include that input. In Comet Global, we're seeking out to make these user inputs dynamic. So if a model requires a parameter called liming that takes in a numerical number and a date and it has units attached to it, we're programming that to be dynamic, okay? So if the model, and I'll back up to the model, the dynamic model, if this dynamic model follows the correct design pattern, the dynamic user interface will automatically create those inputs in the Comet Global platform. This is a really powerful concept. And again, I'd like to show a very, I want to show a proof of concept that demonstrates how this works so that everyone can fully grasp how this, how this is helpful, how this is powerful. But with that dynamic user interface, now we have models that you come in, and the models are, I don't know if I went into this, but they're region specific. Yeah, they're available based on region and certifying agency. Okay, so if I'm in the United States or if I'm in France, there's a region, there's a certifying agency. That's what drives what are the available dynamic models from within the app. So we've got a dynamic user interface. The software engineers, we don't have to go in and create specific inputs for every single model. And then we've got dynamic reports associated with that. So along with the dynamic model design, the initial design, you design a report, you design an output. And that output is going to be specific to your region, your certifying agency, and the models that you ran, okay? So this is really cool. I'm really excited about this one. Everything's cloud hosted, auto-scaling, multi-region. Specifically, this is a .NET Core. If we have any software engineers, .NET Core, React. We want to, React is really common at this point. It also translates really well to mobile apps. So it doesn't translate automatically, but React is, you know, it's the new upcoming front end JavaScript library. It's great. I love it. But we have React Native. React Native is the multi-cross-platform mobile application framework. And so a lot of times, if you have a React design pattern, it actually translates pretty well to React Native. So if we ever want to have Comet Global become a mobile app, we'll be able to reuse large swaths of this code in order to achieve that. So current tool, initial funding provided by Foodshot Global Groundbreaker Prize awarded to the Dr. Keith Paustian. They wanted to award it to me, Kevin Brown, but they decided to award it to Keith instead. That's okay, same team. I'm just kidding. So this is the current screenshot of the live tool. It is working, and we've spent some time on it, a lot of time designing it, and we actually have a first prototype that we aren't ready to share the actual URL, but it is underway, and we actually have a number of completed milestones here that we're keeping track of as we make progress, and we have a number of future milestones that we want to hit here. So here's just a quick demo of the page. Seeing is believing. So we've got our map page implemented, and notice here on the right, notice here, I don't think this is the latest slide. That's okay. Notice on the right, we have a list of spatial layers, okay? And this is the dynamic spatial layer functionality that I'm attempting to show here. And the user is going to click land cover, which is this specific spatial layer is a crop data layer in the United States. And so when the user clicks that crop data layer, what we see is we start to pull in any imagery that's available. And then on the right, you see this legend that was pulled dynamically. So this was available through their WMS service, and our platform is going to pull that, it's going to scrub it, it's going to add it dynamically to this view so that the user can use it. And in this case, it's a legend of the different crop types, right? And so what we want the user to be able to do in Comet Farm, you notice as Keith was progressing through the screenshots for Comet Farm, the data entry burden is, you know, there's a lot of data inputs. And so we want to try and this spatial data, you know, have it be a great set of defaults to allow for the user data entry to be as easy and as quick and seamless as possible. So if we have a land cover data set that provides some rotation data or suggests some rotation data, what we can have is what we'll see here in the next slide, which is auto crop rotation detection. And in this case, we're seeing that it assumed that this is a cornfield and this is a barley field, and it actually populates default data for those two fields and gives the user a starting place. From here, the user can still go in and edit that crop data. They can go in and look at what defaults were populated, edit those defaults, keep them. It'll allow the user to quickly attempt to run a report. So that's really our goal there. And so it can be any number of spatial layers that we can import into the tool as long as they follow that design pattern. And it'll allow the users to have a starting place with default data. So that's just a quick demo of the tool. We do want the prototype to be ready by August 2020. Keith, I don't know if this deadline is going to be determined by determined by our internal team. So this is a loose date, but I think this is a reasonable date. Keith, I don't know what do you think about that?
Yeah, well, we got that for now. Go ahead and finish up, and let's open for some questions here.
Yeah, and that's pretty much it. So yeah, any questions, fire away.
Yeah, thank you, Kevin. I think we have two questions for you. One from Daniel. Daniel, he's saying, is it planned that one can see and use models that are introduced by others, like sharing error scripts or error codes? Yeah,
okay. No, that's a good question. So I think the way that we're envisioning this would be that, that first of all, so within this Comet Global platform, we want to make have a globally available set of methods and data that would be, for example, the methods would be based on IPCC. They would be simpler. We'd be using global data sets. So that would be kind of a default system that would be there. So you could, if you just wanted to use that same thing, you could go anywhere and apply that. But part of the idea of the flexibility here is that, let's say another country, so not the US, but a country in, let's say, Australia or something like that. Australia they might want to use the Ross C model for soil carbon. They might have another model for nitrous oxide. So they would have potentially could have their equivalent to this USDA Blue Book, which is the official methods for the US. The idea being that we could have then this system. So if the user is from Australia and wants to use the official Australian set of tools and data, that would be implemented then within this Comet Global for a user from Australia. Likewise, you could have essentially think of it as variants. So it could be an EU variant. So somebody's saying, okay, I'm doing farm level inventory within the EU. I want it to be fully consistent. Okay, what have the EU scientists set up as the official set of methods that they want to apply EU-wide? There would be a variant that could be used for that. Likewise, if there was even a country within, let's say Denmark said, well, yeah, we like but for some of our own policy within Denmark, we want to use the DAISY model or something else, and we have this other data. You could have a Danish variant that was specific to the requirements and the specifications that within Denmark. So that's really the flexibility of this allows for for that kind of capability.
I don't know, Daniel, if this answers your question. I see he's raising his hand, so if he wants to add something.
Now you can hear me. Yeah, thank you very much for this presentation. It was very interesting. So the question I had is kind of like, say, if a research institution in Australia would adapt the COMET tool to the Australian conditions, say Australian soil map, Australian models, etc. Could then a farmer, say in Australia, see somewhere that this has already been done by somebody else, because he would want to use this like Australian version of the COMET tool, but the farmers should kind of see what kind of model versions already exist and others did, so that he can choose from these set of model versions the one that is best fit to his purposes.
Yeah, I'm not 100%. I think some of these things are kind of still to be worked out, but I guess I'm assuming that the tools are going to be used for a specific purpose, and there will be you know, think of it as a sanctioning organization or something that will be, you know, that will want to sponsor or, you know, promote the use of the tool. And the point is that, you know, this allows, you know, the flexibility so that different groups, different countries that have their own requirements can have those met. So we're really trying to build this, again, a flexible platform that can meet the needs of you know, a number of different groups and countries and individuals and industry, etc.
Yeah, so to add to that, right, Keith said it, but we're using the term certifying agency in the slides. But there, from the architecture of the software, you have to select the correct, you know, the region and the certifying agency. That shows you what models will be available. So in terms of what is available, that's the structure that we're going to hold it in. And as Keith mentioned, the details will need to be worked out in terms of how do we define a certifying agency?
Okay, so I just wanted to say thank you to Amy also, because I see she's answering a lot of questions, but maybe if you want to go back to some of those questions, you have a question about what about the tropical environment or about the range of uncertainty. So if you want to add something about this before we end.
Was that for Amy or? Well, I answered, there was one question about, you know, ferrosols and, you know, tropical soils. And again, I think the question is really what, you know, what is the underlying models within the system have been used. And in the case of that particular question, which I wrote an answer to in the written chat, was that the descent model, which is the model that is currently within the COMET US model, and it could be deployed in other countries, certainly. It's been used by a number of research groups in tropical countries on ferrosols. I know personally I've worked with lots of scientists in Brazil that have used it for looking at sugarcane systems and cropland and pasture systems there, as well as other places in Africa and Southeast Asia, etc. So the underlying models within COMET Farm, in that case, the descent model, yes, it's been used and it seems to be a pretty good model in most soils, you know, that are around the world in most environments. But again, the point of this system would potentially would allow for, if there was a country that had their own model that they thought was the best model on tropical soils for their country, that would be a model that could be hosted within a COMET Global version that is attuned to their needs.
Okay, thank you. So yeah, I think one of the messages that this is a huge work that could be used in another context. And maybe one last question. I don't know if we have time. Okay, just last question. Eleanor, she's asking if she has more than 2 models. In this case, she could produce 2 different reports if she used 2 different model routes.
Well, again, you know, the idea would be that if you're, you know, that if you're working within a particular, you're using a particular variant of the system, there would be one set of methods within that variant. So it would, again, so if you're using Comet Global in Denmark, and the Danish government or whoever the certifying agency is says, you know, they've defined the methods and models and data sets, then that would be what you would be getting. So you wouldn't be able to, you know, we're not making this so that every individual can build their own custom version of COMET Farm using, you know, whatever data, whatever models they want to put together. That would be, you know, I think that would be a little too flexible, perhaps. But
okay. So I think we don't have time to all those questions, but you can always contact us if you have more questions. So thank you everybody to come. Thank you Keith and Kevin for these great presentations. Also Amy for helping us with the answers. If you have a question, please contact us. We'll be putting this video on our YouTube channel if you want to see it, and you can share it, of course. So thank you again.
I would also say that if folks want to follow up, they can send me an email, and we'd be happy to dialogue offline with you.
Of course. Well, thank you very much, and I must say goodbye to you all.
Okay, thanks, Ari. Thanks, everyone.
Bye-bye.
Bye-bye.